Hey guys, so here are the notes for 7.7 day 2. So far we have learned how to solve for a missing side of a triangle and how to find a missing angle. Here, that's what we're going to do. We're going to be solving right triangles. Okay, so when we solve right triangles, we are always solving for three things. Okay. If we are solving for two sides and an angle, this is what we'll have to do. Okay, so solving for two sides, what we will have to use are trig ratios. So remember, that is our SOHCAHTOA. And then when we are solving for just the one angle, what we need to do is add up the other two angles and then we're going to subtract from 180. So I would suggest kind of writing this down, because when you're doing these problems, this is what I would suggest. Figuring out, okay, do we need to solve for two sides and one angle or one side and two angles? Okay. So if you need to, make sure you pause the video to get all of this down. Okay. Now, the other way we could solve for three things is when we have one side and two angles. So to get the one side, we're going to use the Pythagorean Theorem. So remember, that is our a squared plus b squared equals c squared. So that's the first thing we did in this chapter. And then if we have to find two angles, how we're going to do that is use inverse trig ratios. So that's what you learned in the 7.7 day 1 notes. Okay. So that's what we're going to do. Whenever we're solving for right triangles, we're going to figure out what we are solving for and then use those methods to solve. Okay, make sure you have this written down. Let's go and get to our first example. So we're going to solve the right triangle, and it does tell us we're going to round any decimal answers that we get to the nearest 10. Okay, so notice here what we are going to solve for. Now, on the homework assignment, it will kind of just tell you what you're going to solve for, so that's going to be a little bit easier. So here we're going to solve for, it looks like, one angle and two sides. So since we're doing this, remember, if we are finding one angle, we're going to add up and subtract from 180. And then with the two sides, we're going to go ahead and use trig ratios. Okay. So we can definitely see we're going to have to solve for B, and then we have to solve for AC and BC for those sides. Okay, I'm going to write that down so I know what I need to solve for. So we're finding the measure of angle B, and then we're going to find AC and BC. Okay, let's go ahead and do our work here. So to find the measure of angle B, we're going to go ahead and do 180 and subtract it from the two other angles that we have. So the other two angles we can see is, of course, the 90-degree angle. That is always going to be a given. And then the 23 degrees, which is our angle A. So I'm going to add up 90 and 23. So you're going to see that in the parentheses. And once I get that, I'm going to do 180 minus that value. So remember, you shouldn't get any negative angles. If you do, relook at your work. All angles and all sides need to be positive. So we add up 90 plus 23. That gives us 113. Now we do 180 minus 113. And we should get 67. And don't forget the degrees because we are finding the angle measurement. So 67 degrees is going to be our angle B. Okay, now let's find AC. So this is where we're going to have to use our trig ratios. So I'm going to go ahead and mark our angle A because that is going to be our acute angle. Now you can also use angle B if you want to. It's actually up to you which angle you want to use to find the sides of AC and BC. Okay, so since we're finding AC first, notice here, AC is right next to 23. Remember the words next to means adjacent. Now the only other side that we are given is that AB, 40 feet. Notice that's across from the 90-degree angle. Anything or any side across from the 90-degree angle, that is our hypotenuse. So we have adjacent over hypotenuse. What are we going to use? Notice I already have SOHCAHTOA here. Right? So if we have A and H, that's going to represent our cosine. So we're going to go ahead and do cosine there. So I have cosine of our 23 equals, our adjacent side was AC, so I'm going to leave that as AC, over our hypotenuse, which was 40. So now I'm going to go ahead and make this into a proportion, and I can cross multiply. So AC times 1 is just, of course, AC. And then I have 40 times cosine of 23. So now I need to plug that into my calculator. Okay, now make sure that in your calculator it is in degree mode. So it should say degree or DEG. If not, make sure you press the mode button. Then you're going to go down to where radian is and right arrow over to degree. Press enter and then do second mode to quit out. Okay, so let's go ahead and plug this value in. So we have 40, so we do the number 40. Then we do times. Now I have to do cosine of 23, close the parentheses, and enter. Now remember, it told us that we're going to round to the tenths place. So at 36 point, notice there's a 2 after the 8, so I keep it as 8. So I have 36.8. And this does not have a degree sign because it is a side. Okay, now we're going to do BC here, BC. I'm going to keep using my 23 degrees. If you want to switch and do your angle B of 67, that is fine as well. So if I look at 23 and compare it to the side of BC, notice that it is a cross from that angle. Remember, anything across from it is going to be the opposite side. And I'm going to keep my hypotenuse, so I'm also going to use that. So notice I have O and H. If we look at SOHCAHTOA, notice that sine is going to have our O, which is opposite, and hypotenuse, which is H. So I'm going to use sine of 23 equals BC over our 40 here. And once again, I'm going to make this into a proportion. So to make that sine of 23 into a fraction, put it over 1. I cross multiply. So I get BC equals 40 times sine of 23. We're going to plug this into our calculator. So now I have 40 times sine, so that's what we want to use here, of 23, close your parentheses, and this is going to be 15.6. And once again, since it's a sine, no angle measurement. Okay, make sure you watch the next video. We're going to do the second example of solving the right triangle.